All right, so we are going to go over this worksheet, the mole to mass conversions worksheet. And I've got handy dandy Apple Pencil here. Stole my husband's iPad so I can help you guys with this. So what we're doing here is using the molar mass. When you see molar mass, I want you to think atomic mass, but in grams. Okay? All right. Molar mass equals atomic mass, but in grams. Okay? So what does that mean to you? So if I am told that 1 mole of a substance is its atomic mass in grams, what does that even mean? If I'm told that I have 1 mole, whoops, don't want an eraser. If I'm told I have 1 mole of chromium, that means I have 6.02 times 10 23rd atoms of chromium. I also know, based on what the periodic table tells me, that I have 52 grams of chromium. Okay, these are all the same thing. So let's take that knowledge and apply it to this problem, problem A. So if I'm given 10 moles of chromium, I need to convert that into the mass. So if I know that 1 mole of chromium equals 52 grams, then all I need to know is 10 moles times 52 grams of chromium per mole of chromium. Let's put a CR there. 1 mole of if I'm given 10 moles of chromium and I know that there's 52 grams of chromium per mole of chromium, I'm going to cancel out these units and I'm going to multiply 10 times 52, and that's going to get me 520 grams of chromium in 10 moles of chromium. All right, this looks a little sloppy here. So let me erase this and I will make it a little bit prettier for you. Bear with me, y'all. So again, I'll rewrite this for you. I have 10 moles of chromium. And I'm going to multiply that by my conversion factor, which is also just looking at the periodic table and seeing that I have 52 grams of chromium in every mole of chromium. How do I know that? Because molar mass is the same as its atomic mass, which is what it's displayed on the periodic table. And molar mass is basically the mass of 6.02 times 10 to the 23rd atoms of that element. So now that I have this set up, I'm going to cross out these units because they cancel out. And then I'm going to multiply the 10 times the 52 grams of chromium. 10 times 52 is 520 grams of chromium in 10 moles. So in 10 moles of chromium. All right. That is my answer. So let's move on to H2O. All right. So first we need to calculate the molar mass of H2O. So let's do that. In 1 mole of H2O, I have my atomic mass or molar mass of hydrogen, which is 1.008 times 2, plus the atomic mass of oxygen, which is 16. There's no subscript, so I'm going to multiply 1 times 2, so I've got roughly 2 plus 16. So the molar mass of H2O is 18 grams of H2O per 1 mole of H2O. Okay, so for 6.02 times 10 to the 23rd molecules, or 602 hexillion molecules of H2O, that's about 18 grams. That's not very much. So what if I have 0.160 moles of H2O? What does that look like? So we found our molar mass, and what we're going to do is the same thing we did in the first problem. We're going to take what we have, 0.160 moles of H2O, multiply it by my conversion factor, which is up here, 18 grams of H2O per 1 mole of H2O. All right, see these units, moles of H2O, they cancel out. All right, so all we're left with is this multiplier, 0.160, and 18 grams of H2O. So I'm going to multiply this times 18 grams, and that is going to equal, one moment, let me get my handy dandy calculator out here, 0.160 times 18. That is going to be 2.88 grams of H2O. Now let's take a step back and see if that makes logical sense. So if 1 mole of H2O is 18 grams, then I know that since 0.160 is way less than 1, it's a 16th of 1, then I know that we're going to have less than 18 grams. All right? I hope that makes sense. So let me erase this. Oh, it's much faster with my finger. All right. Scroll back up. Let's work on the next one. So I'm given 3.32 moles of potassium. So let's find the molar mass of potassium. And by looking at the periodic table, I can tell that that is 39.10 grams of potassium per 1 mole of potassium. All that means is that 1 mole of potassium equals 6.02 times 10 to the 23rd atoms of potassium. And that also equals 39.10 grams of potassium. Okay, these are all the same thing. All right, so when we have this dividing line, it doesn't mean that we're necessarily dividing it, it means per. All right, so 39.10 grams of potassium per 1 mole of potassium. So knowing that, let's go ahead and do our problem. So we are given 3.32 moles of potassium, and we need to multiply that by our conversion factor, which we know to be 39.10 grams of potassium in every mole of potassium. Okay, so our units cancel out, moles of potassium, and all we're left with is 3.32 times 39.10. Let's plug that into our calculator, 3.32 times 39.10, and we are left with a 129.812 grams of potassium. We're not going to worry about significant figures here. So does this make logical sense? If 1 mole of potassium is 39.10 grams, then we know that 3 moles of potassium is going to be much larger than 39.10 grams. So about 3 times larger. So 39 or maybe 12 times 3 is roughly 120. All right, so rounding, yeah, that makes sense. All right, so let's move on to the next one. This one's a little bit trickier. We are given 5.08 moles of calcium nitrate, I believe is what that is. Calcium nitrate is the common name for that. So what we're going to do is we're first going to calculate the molar mass of calcium nitrate. So first we need to look up the atomic mass of calcium. So the atomic mass of calcium is 40.08. So since we're using it as molar mass, we are going to say calcium's molar mass is 40.08 grams of calcium per mole of calcium. You can put the 1 there. You don't necessarily have to because it's implied. All right. So we've got 40, and then we've got the molar mass of nitrogen, but we have to apply this subscript here. This little subscript of 2 applies to everything inside the parentheses. So that means I have 2 nitrogen. So what I'm going to do here is I'm going to say we've got our 40.08 grams of calcium. Let's put that in parentheses. Plus, we've got 2, because we have 2 molecules of nitrogen, 2 times, what is the molar mass of nitrogen? It's 14.01 grams of nitrogen. And then I'm going to add our last molar mass, and that is oxygen. So that's going to be 2 times 3, because these act like exponents. 2 times 3 is 6. So 6 times the molar mass of oxygen, which is 16 grams of oxygen. All right, so I'm just going to do that math. So here we go. Let's do the multiplication first. So 6 times 16. So I've got 96 grams of oxygen here. 2 times 14.01 is, could have done that in my head, that is 28.02 grams of nitrogen. I'll leave myself room here. And then we've got our regular 40.08 grams of calcium. My handwriting is not much better on this. All right, so let's do a quick math. 40.08 plus 28.02 plus 96 equals, drum roll, 164.1 grams of what? Of calcium nitrate. All right, so we've only done the first part of the problem. First, we had to find the molar mass. All right, so that is 164.1 grams of calcium nitrate per mole of calcium nitrate. All right, so now that we have our conversion factor, our molar mass for calcium nitrate, we can actually calculate what 5.08 moles of calcium nitrate looks like. So let me go ahead and erase the majority of this nonsense here. I'll leave my conversion factor down there so we can see it. So let's take what we're given. We are told that we have 5.08 moles of calcium nitrate. All right, so then we're going to multiply that by our conversion factor, which is 164.1 grams of calcium nitrate per mole of calcium nitrate. All right, so these units cancel out, moles of calcium nitrate. And we're left with 5.08 times 164.1. So 5.08 times 164.1 equals 833.628 grams of calcium nitrate. That is how much roughly 5 moles of calcium nitrate weighs. Does that make sense? Absolutely, because we have 164.1 grams of calcium nitrate per mole. So if we have 5 moles, it's going to be about 5 times larger. So this times 5 is about 833. So that makes logical sense. Let's go ahead and erase this. Let's move on. I think we've done, oh, let's do this last one because this has some scientific notation in it. All right, so we are looking at the molar mass of tin, and that is, so SN stands for tin. The molar mass of tin is 100, oops, I don't need the eraser, is 118.7 grams of tin per mole of tin. All right, so that's my conversion factor. So what on earth are we doing here? Don't be frightened by scientific notation. It's not that scary. So first we need to move the decimal place because that's all this means, is that this decimal place is not really here. So if I have a negative, that means I move my decimal place to the left 1, 2, 3 spots. So I put it there, which I'm going to have a 0 here, 0, 0. So let's rewrite that. We have 0.00220 moles of tin. Now I'm going to multiply that by my conversion factor, which is right there. I'm not going to rewrite it. So then my moles of tin cancel out. So I have 0.00220 times 118.7. So this is just a tiny fraction of a mole of tin. So 118.7 times 0.00220 equals, this is a very tiny amount of tin, 0.26114 grams of tin in that much moles of tin. All right, so that's the only thing that you would have to do with scientific notation. So let's move on and let's work backwards. Say we are given the weight or the grams of a substance. We need to calculate how many moles that is. All right, so let's start with argon. Argons, let's figure out our conversion factor first. So 1 mole, we're going to write it backwards this time. So a mole of argon is, there's 1 mole of argon per 39.95 grams of argon. All right, so the reason why we did that is because we're solving for moles, and if we put the grams of argon in the denominator, then that unit is going to cancel out when we multiply it with this. So if we cancel this out, what this really means is that we are just going to divide 72 by 39.5, and that equals, so basically this moves over right here. And then we've got 72 divided by 39.95. And that equals 1.80, we'll just say 2 moles of argon. Okay, that's our answer. Does that make sense? Well, let's look at this. There's 39.95 grams of argon in every mole. So if I have 72, that's almost 2 times more grams than I would have in 1 mole. So it's almost 2 moles larger. All right, 2 times larger. Let's find the first, for the next problem, letter B, let's find the molar mass of nitrous oxide, nitrogen dioxide. Goodness, my brain. All right, so we have nitrogen, which is, don't need the eraser, 14.01 plus 2 times 16, which is the molar mass of oxygen. So 14.01 plus 32, because 2 times 16 is 32. 14.01 plus 32 equals, don't make fun of me, y'all, I'm using a calculator, plus 32. And I keep pressing the wrong buttons. All right, let's do it in our heads. 46. Very good. Good job, Mrs. Bacon. All right, 46 grams of NO2 per mole of NO2. So let's rewrite this. Let's flip-flop these. And we'll say for every mole of NO2, we have 46.01 grams of NO2. Okay, so that's my conversion factor that I'm going to use. And I want to use that because what we're solving for is on top. So let's take what we're given. Let's say we've been given 27.4 grams of NO2. And we multiply that by our conversion factor. So moles of NO2 over 46.01 grams of NO2. Cancel out these units, grams of NO2. And all we're left with, pretend this moves over here, we're going to have 27.4 divided by 46.01. 27.4 divided by 46.01. That is 0.596 roughly. And that's going to be, remember these units right here, moles of NO2. All right, let's think about that logically. If there's 46.1 grams of NO2 in every mole, if we have less than that, then that's going to be less than 1, okay? I hope this is making sense to you. So let's erase that. We'll move on. Let's do, this one looks a little bit tricky. So first, let's find the molar mass of lithium phosphate. I believe is what that is. Or phosphate, I'm not sure. So we have, let's take 3, because there's 3 lithium atoms, times its atomic mass, which is 6.94, also known as its molar mass. So we use grams. I've been forgetting my units when I did this earlier. Plus the phosphorus. So the atomic mass is 30.97. The molar mass is 30.97 grams, 30.97 grams. And then I'm going to do the molar mass of 4 oxygens. Whoa, where are you going? All right, 4 oxygens, 4 times 16 grams. So let's simplify this a little bit. 3 times 6.94 equals 20.82 grams plus 30.97 grams plus 4 times 16 is not that. 4 times 16 is 64. I should have done that in my head. All right, so then let's add these together. 64 plus 30.97 plus 20.82 equals 115.79 grams. And that is grams of lithium phosphate, Li3PO4. Okay, that is what that is. So there's 115.79 grams of lithium phosphate per every mole of lithium phosphate. Man, just really struggling with the writing right now. PO4. All right. So now that we have our conversion factor, I'll erase everything but the conversion factor. It's a little sloppy over there. So let's take what we're given. We've got scientific notation here, so we need to move our decimal point 4 places to the left. 1, 2, 3, 4. There's my decimal point, and I've added 1, 2, 3 zeros. So let's rewrite that number. We've got 0.000264 grams of lithium phosphate. And I'm going to multiply that by this conversion factor with what I'm solving for in the numerator spot. So moles of lithium phosphate for every 115.79 grams of lithium phosphate. And that means these units are going to cancel out, grams of lithium phosphate, grams of lithium phosphate. This kind of moves up here, and then we're going to take 0.000264 divided by 115.79. This is a very tiny number. So first, let's write it in regular notation, then we'll convert it to scientific notation. So 0.000228. What are my units? Moles of lithium phosphate. So this is not a very pretty number, so let's go ahead and use scientific notation. So let's write, we know that our scientific notation is going to look like this because we want our decimal point to be right there. So I'm going to write 2.288, not 3. And then I'm going to count how many decimal places to the left our old decimal point was. So I'm going to go 1, 2, 3, 4, 5, 6. So I'm going to go times 10 because I went left to the -6. And that's moles of lithium phosphate. Okay, that is the answer to letter F. And that is the last problem I will do with you and for you for your mass mole conversion worksheet. All right, I'm going to post this on YouTube. So please let me know what questions you have or if I can clarify anything or if you'd like me to go over a specific problem, and I would love to do that. Otherwise,